Today we're looking at these three rules of differentiation: the product rule, quotient rule, and the chain rule. So feel free to take a picture or screenshot what's on screen now. These are the rules. We're going to be using them later in the example. So let me quickly explain them first. So for the product rule, we have f of x, a function, times by g of x, another function. So the derivative of this product is going to be the derivative of the function f of x times by g of x plus f of x times by the derivative of the function g of x. Now for the quotient rule, we're doing the derivative of a function f over another function g. So this is the formula for this differentiation. And what happens is, first of all, we take the derivative of f of x times by g of x, and I'll note the negative here, minus f of x times by the derivative of g of x, all over g of x squared. And that's not g prime squared, it's g of x squared. Okay, so the chain rule, we're doing the derivative of a function where there's another function within it. So f of g of x. So this is the result of our differentiation. We have f prime of g of x. So g of x is a placeholder for our variable, times by the derivative of this g of x. Alright, so let's jump straight into the examples. Alright, so here's our first example, and it's of the product rule. So we're asked to differentiate x squared times sine of x. So our first term, or our first function, will be x squared, and our other function will be sine of x. So first we do the derivative of x squared. We know that to just be 2x, times by sine of x, leave it as itself, and then plus, we leave x squared, times by the derivative of sine of x. So the derivative of sine of x is cos of x. And that's the final answer for this question. Okay, so here's our next example, and it's an example of the quotient rule. Try it for yourself first and see if you get it right. Of course, still using the formula for the quotient rule. So, first off, we're going to take the derivative of the numerator, which is 2x, because the derivative of x squared is 2x, minus 4. Because the derivative of negative 4x is negative 4, and then the derivative of 7 is 0. So that's the derivative of the numerator, times by the denominator, or the denominator's function, which is x cubed minus x. And now there's a subtract sign. So now we're not differentiating the numerator, we're differentiating the denominator. And we're leaving the numerator as is. So let's leave the numerator here, and we say x squared minus 4x plus 7. And then we differentiate this denominator. So x cubed becomes 3x squared, and negative x just becomes minus 1. And then this is all over the denominator's function squared, which is x cubed minus x squared. So of course you can go now and simplify this function, but you're really here for the differentiation, so I'm not going to waste your time and do that. So this is the final answer. Here is our example for the chain rule. So we have the derivative of sine squared of 4x cubed. Okay, so after this example, I'm going to do an example that incorporates all the three rules in one big derivative, so make sure you stick around for that. Alright, so let's go ahead and tackle this derivative. So first of all, we're doing the derivative of the outermost function. So this function can actually be written like this: sine of 4x cubed, and then that squared. So first, we use the power rule. So it's 2, because of this 2, we multiply this inner function by the exponent. So 2 sine of 4x cubed. So now we get rid of that, and now we look at here. So the outermost function now is sine. So times by cosine, because the derivative of sine is cosine. And we keep what's inside still, 4x cubed, and then once again we have another chain rule integrated in, and so now we've gotten rid of that. So the outermost function is now this 4x cubed, so we times by 12, because 4 times 3 using the power rule is 12x squared. And once again, you can simplify that. And obviously this 2 and this 12 will become 24. The final example that contains all these 3 rules in one is as shown on screen. It's the derivative of arctan of x times by the natural log of 2x all over x cubed plus 1. So first of all, I noticed that this is going to need the quotient rule, because there's a fraction with functions in the denominator and in the numerator. And I also know that this is going to need the product rule, because we have a function times by another function. And I also know that this is going to use the chain rule, because I have a function nested within this natural log, which is 2x. So let's go ahead and use the quotient rule first and see how it goes. So for the quotient rule, we know that the denominator is going to be squared all the way in the bottom. So I'm anticipating quite a large numerator with a lot of terms. So I'm drawing a large line, x plus 1 squared. Alright. So now we have our numerator here. And so it's a good idea to now compartmentalize all of this and to do different derivatives separately so that you can put it all together neatly. So I'm going to say over here, the derivative of arctan of x times by the natural log of 2x is equal to this. So this is product rule, so we can go ahead and say the derivative of arctan of x is 1 over 1 plus x squared, and then this is still times by the natural log of 2x, which remains the same, plus arctan of x over, because now we're doing the derivative of the natural log of 2x, so 2x, and then within there, which is where the chain rule's coming in. So first the outermost function was the natural log, so the derivative of the natural log of a function is 1 over that function, so 1 over 2x. But now the 2x needs to be differentiated as well. So 2x differentiated simply becomes 2, and that's very convenient because those 2's can cancel out. So there we can get rid of them. And now we know the derivative of the numerator, which is going to be very useful because within the quotient rule, we have the derivative of the numerator, which is now just going to be this. So I'm going to copy that. And I'm going to paste it over here. Times by the denominator left by itself as it is, x cubed plus 1. And then minus, don't forget. And now this is the numerator left as it is. So arctan of x times by the natural log of 2x times by the derivative of the denominator. So that's simply 3x squared. So that solves this large differentiation that involved all 3 of these rules, the product rule, quotient rule, and chain rule. I hope you got it right beforehand. And if you did enjoy this video and found it useful, please don't forget to leave it a like and subscribe. It really helps me out. I'll see you tomorrow for day 80.